Hi, in this video my group will demonstrate all the related sections provided in assignment worksheet using Raspberry Pi and Raspberry Pi simulator. By the end of this assignment, we will able to demonstrate the technology of Ethernet communication and in-output peripheral in a computer system. Besides running the project on Raspberry Pi hardware, there is another way to run the project is using the virtual Raspberry Pi by installing the simulator on the computer. The reason using Raspberry Pi simulator is because it allows users to write the code to control the emulator hardware, and it also allows the beginner to interact with the Raspberry Pi who does not have. Next, I will show the step how to install the Raspberry Pi simulator to our computer.
First, we go to the following URL, download the VirtualBox. Choose the latest version and download to our computer. In here, I'm going to choose the Windows platform. Once the download completed, we can start to install it on our PC. Then go to the following URL, download the Raspbian OS image for later usage. First, open the VirtualBox and click New. Key in the project name. Due to we need to run the Raspberry Pi simulator in VirtualBox, so at here we select the OS type to Linux and version to Debian 32 bits. Then click Next. We set the memory to 1024 MB and click Next. Create a virtual hard disk and select BHD. Here I use 8 GB volume for my virtual Raspberry Pi storage. After this, we can see our simulator information at the menu, and we can begin our Raspberry Pi simulator. Click Start. Then we need go to our download directory to select the Raspbian OS image that we downloaded just now, become the startup disk. Now we can see the VirtualBox is putting the Raspbian image. Our installation is successful.
My name is Tham Yee Yant. Today I will present about the section B on the process of booting the Raspberry Pi. All the process are shown in this slide. When we turn on the Raspberry Pi, the ARM core is off and the GPU core is on. There are 3 stage bootloader in this process. Then the GPU will start execute the first stage bootloader, which is to read the SD card and load the second stage bootloader into L2 cache and run on it. Then the second stage bootloader will enable the SDRAM and will read the third stage bootloader from the SD card into RAM and run it. Therefore, the third stage bootloader will read the GPU firmware. The purpose of the loader.bin is to load the start.elf at the top of the memory, while the purpose of the start.elf is to read the config.txt, cmdline.txt, and also the kernel.image. These are all of the process of booting Raspberry Pi. Thank you.
This section I will show you how to using the Raspbian terminal window to observe the Raspberry Pi virtual memory. So we can monitoring the performance of Raspberry Pi by referring the virtual memory statistic.
first of all, we need to open the terminal window in desktop and type the vmstat command. Then the terminal window will display the one line of data beneath a two-line column header. This is showing the state of the virtual memory system at the moment when the command was launched. Actually, all of these symbols at the column have the meaning. If we don't understand what is the symbol representing, then we can refer this table to understand the meaning to evaluate the Raspberry Pi status.
Now I will present the section D on how to program the GPIO on Raspberry Pi. GPIO provides the layout and enable the control of the connection input and output, which turn the Raspberry Pi into an embedded control system. This figure shows the layout of the GPIO on the Raspberry Pi 3. Now I will demo on how to program the GPIO using Raspberry Pi 3. To program the GPIO, the Python language is used. To know the version Python on this Raspberry Pi, we can run this code to see the version of the Python. This shows the version of the Python on the Raspberry Pi 3. Then for a first time to program the GPIO, the Python GPIO library is installed by using this command. After install the library, we can use these three lines of coding to control the GPIO pin. The first line of this code is to import the GPIO library by using this code. Then the second code is to specify the layout of the GPIO pin. Here we can choose the layout on the board or on the Broadcom. In here we choose the layout on the board. Then the third line is we set the GPIO pin 12 as an output. Then we can run this code in terminal to see the result. By using this command GPIO read all, the table will show. Now we can see that the GPIO 12 now is set as an output. We can also control the GPIO as an input by using this command. So again, by using this GPIO read all, the table is shown and the GPIO 12 is now changed into input. As before this, the GPIO 12 is output. Now it changes to input. Now I will end my presentation. Thank you.
Good day everyone, I'm R.Ashvin Rajamohan. I'm here to explain on the section E of this assignment, where it is about the building a simple circuit on Raspberry Pi. and I'm using a Raspberry Pi Zero due to limitations where I can only able to get this model. And on section E, we are about to see building a simple circuit using a emulator on Raspberry Pi. So to install the emulator, we are about to unzip this file from the given website on the assignment sheet. And once we unzip the file, we are required to perform some coding on Python 3 IDLE. Okay, so we are about to open the file that we programmed earlier. Yeah, so this is the web. So as the first line of the coding, we are importing the emulator that we installed earlier, and import time, traceback, and request. And apart from that, we are about to set the mode of the pins that we are about to use. So first of all, we are using pin number 4, where pin number 4 is used as an output pin, and as same as that, pin 17, 18, and 21 is also used as an output pin, but the initial value of it is set as 0. It is set to low. And there are other 4 pins which are set as an input pins, which are 23, 15, 24, and 26. These pins are also set up as a push button to later simulate in a later to test in an emulator. So first of all, the pin number 23 works as a push button where where high when not pressed. It will be stay as high when it is not pressed. And as about 15, pin number 15, it will be low when it is not pressed, as same as 24 as well. And 26 is also an input pin. As we design the circuit, is when there is no input at pin number 23, pin number 4 and 17 will be triggered high, and where is an input at input 15, then pin number 18 and 21 will be triggered high. And when there is an input at input 26, pin number 4 and 17 will be triggered as low. So we are about to test the code, pressing run module. So there is the emulator. Okay, so first of all, we are going to test pin number 23. So when we press pin number 23, okay, so as we press pin number 23, pin number 4 and 17 is triggered as high, and we are about to jump to pin number 26 now. When we give an input pulse at 26, then it is triggered as low. And as you could able to recognize over here, input 23 is triggered as high when it is not pressed. So we are about to test on pin number 15 now. When we press on pin number 15, the output pin 18 and 21 is triggered as high. But the problem that on this code is we are unable to change it to low, because we don't have such codes to trigger it as low for pin number 18 and 21. So based on the problem that we discussed earlier, where pin number 18, output pin number 18, couldn't be triggered as low, so we have made a few changes on this code, where we have add on this part. So when there is no input at pin number 24, then pin number 18 and 21 will be triggered as low. So this is pin number 15. We are triggering as high. So we got pin number 18 and 21 triggered high. So when we click on 24, it will be triggered as low. And this works as previously how it works. And this is the new one. So this is how the GPIO concept works. So in real case, we can just replace all the inputs with some sensors, and depends on the input of the sensors, we can actually code our outputs. Maybe the output can be an LED or a buzzer or something. So that's all from me. Thank you.
Hello, good day everyone. I'm Thinesh. I'm here to explain about the part F of the assignment. Okay. In part F, we are about to demonstrate the functionality of Wi-Fi and Ethernet on the Raspberry Pi. We begin with the configuration of the Ethernet port on Raspberry Pi by executing the command ifconfig eth0 at the terminal. ifconfig used to configure or view the configuration of the network interface. Okay, ifconfig stands for interface configuration. It is used to view and change the configuration of the network interface on your system. Okay. Running the ifconfig command with no additional argument will display you information about all network interface currently in operation. Okay. The ETH0, LO and WLAN 0 are the names of the active network interface on the system. ETH0 is the first Ethernet interface. Okay. ETH is the first Ethernet interface. Additional Ethernet interface will be ETH1, ETH2 and etc. So this type of interface is usually NIC connected to the network by category 5 cable. Okay, now I'm going to explain about viewing the configuration of a specific interface. To view the configuration of a specific interface, specify its name as an option. For instance, ifconfig eth0. So if you want to configure the specific interface like ETH1, it could be ETH1, ETH2 and etc. So when we are configure a specific interface, it will display the configuration of the device. Example, now I'm configure with ETH0, so it will configure the configuration of a device ETH0 only. Okay. It will enabling and disabling an interface. When a network interface is active, it can send and receive data. When it is inactive, it is not able to transmit or receive. Okay, we can use ifconfig to change the status of the interface from inactive to active or vice versa. Okay. To enable an inactive interface, provide ifconfig with the interface name followed by the keyword up. For example, if you want to configure if let's say the ETH0 is inactive, so we just with the configure ETH0 up, so it will automatically active the interface. Okay. So for enabling or disabling a device requires super user's permission. So you will either have to be logged in as a root or prefix your command with sudo. So as I mentioned before, to activate the ETH0, you have to type the command ifconfig ETH0. So in additional, we have to add with the sudo in front of the ifconfigure. At the end, we just add with the up command. so it will automatically activate the interface. The main function of the sudo command is to run the command with the super user privilege. For example, if the network interface ETH1 is inactive, you can activate it with the command sudo ifconfig ETH1 up. Okay, let's move on with the demo. Here you can see we are typing the command ifconfig ETH0. So it will show you the ETH0's information, interface information with the IP address, etc. So now we will check with the status of the ETH. So we can see ETH0 there is a configure. So now we will move on with the sudo command to activate the super user privilege. So the command will be sudo ifconfig ETH0 down. So we are deactivating the configuration, I mean the interface. So as we can see, the link is down, ETH0 link is down. It indicates that the interface is deactivated, so it cannot transmit or receive any data. So again we are using a command to activate the ETH0 back. To activate back, we just enter the command with sudo ifconfigure ETH0 up. Okay. So as we can see now, the link is up and configuring. Okay, now we move on to iwconfig. iwconfig is similar to ifconfig, but is dedicated to wireless interface. As you know, the ifconfig is dedicated to Ethernet configuration or Internet interface. So the iwconfig is dedicated to wireless interface. It is used to set the parameter of the network interface that are specific to the wireless operation. Okay, for example, the wireless frequency. So iwconfig may also be used to display those parameters. As I said before, as I mentioned before, the frequency and the wireless statics. Okay. So now we move on with the example. First, we got the command tab. Okay. And then we will check with the Wi-Fi connectivity first. As you can see, the Wi-Fi is turned on. So we'll move on with the configuration. Okay. So iw, as you can see, the iwconfig showing off, and so it means that there is no connection. There is no wireless connection or Wi-Fi connection to the Raspberry Pi. Then now we turn on the Wi-Fi. So we are using the same command as before. Okay. As we can see the name of the Wi-Fi connector. So the name of the Wi-Fi connected, and you also can see the frequency as we mentioned before, the frequency, the parameter and the statistics of the Wi-Fi, the frequency, the bit rate, the transmission power. So that's all. Thank you.